Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 16, 2025, about 3 days ago. This paper introduces a new method for 3D point tracking that shows a massive 61.8% relative improvement on a key industry benchmark. The paper is titled SpatialTrackerV2 to 3D Point Tracking Made Easy 2507.12462v1, and the approach here is really quite elegant. It robustly tracks the 3D movement of points using video from just a single camera by unifying scene geometry, camera motion, and object motion into one streamlined pipeline. So to really see what this looks like, the authors provide these great visuals. We see a robotic arm, cars drifting, and a snowboarder. In each case, the model generates colorful lines. These are the 3D point trajectories, showing the path that points on a moving object take through space. It's also estimating the scene's 3D shape and the camera's motion, all from a single video feed. The paper evaluates this using metrics like average Jacquard, which measures how well a predicted path overlaps with the true path. Alright, so how does it actually achieve this? This diagram lays out the whole pipeline. It's a two-stage process. First, the front end takes the input video and estimates two key things: a consistent video depth, which is essentially a 3D map of the scene, and an initial rough estimate of the camera's path. Then, the back end takes over. It uses a novel component called a SyncFormer, which is a special transformer model to jointly refine the 3D point tracks and the camera poses together, making them both much more accurate. Diving into that SyncFormer component, this diagram really shows its clever design. It takes the initial rough estimates and refines them iteratively. It has two parallel branches, one for 2D information from the video frames and the other for the 3D spatial data. Each one creates an embedding, which is a compact numerical summary that the model can work with. The crucial part is how they interact using cross-attention, a mechanism that lets them share information. This allows the model to jointly refine both the 2D and 3D tracks together, producing a much more accurate final 3D trajectory. Moving to the results, this table really puts the performance into perspective. It compares this new method against others on the TAP-Vid 3D benchmark. The key metrics are average Jacquard, which again is about path overlap, and average 3D position accuracy, which measures how close the predicted 3D points are to the real ones. And the results are just dominant. Their model achieves an average Jacquard of 21.2, a huge 61.8% jump over the next best competitor. This result really validates their whole unified approach to tracking. Building on that, this next table breaks down one of the key subtasks: video depth estimation. Remember, this is a core part of their unified pipeline. The table compares their model using two metrics. First is absolute relative error, which is the average depth error, so lower is better. The second is delta 1.25, which measures the percentage of pixels with highly accurate depth, so higher is better. And across the board, their method is just exceptional. It achieves the best average scores, showing that its ability to understand scene geometry is state-of-the-art. Okay, so the final piece of this unified pipeline is camera pose estimation. This table evaluates that specific task across 3 datasets. It uses metrics like absolute trajectory error, which measures the overall error in the camera's predicted path, and relative pose error, which checks the error between consecutive camera positions. And again, their full model is just outstanding. It achieves the best or second best scores in nearly every category, matching or even beating the previous leader, Megasam. This result really shows their unified approach is also state-of-the-art at tracking the camera's motion itself. So to wrap things up on SpatialTrackerV2, we've seen how it excels at depth estimation, camera pose, and overall 3D tracking. The big takeaway here is that by unifying all these tasks into a single end-to-end differentiable pipeline, which just means the whole system learns together from start to finish, the model establishes a new state-of-the-art. It's not just about the huge benchmark improvements. It's also robust enough to work on casual internet videos, which is a massive step towards real-world applications. That's all for this edition of the AI Research Roundup. Thanks for listening.